In this video, we're going to wrap up section 5.3, doing part 3. We're going to start off with this formula called change of base formula. And so we're going to start off with changing log bases. Now, most calculators, and by the way, you will need a scientific calculator. You can use one if you own one, or use one on the iPad, or even on a computer, or your phone. Most calculators have buttons for both common logs and natural logs. Remember, a common log has base 10, and you can use the change of base formula to change your base to 10 or e if it's ln, the natural log, and then solve using the calculator. So for the change of base formula here, if we have log base b of m, and if you can't do it with a calculator, you would need to change it using the change of base formula to log base a of m divided by log base a of b. Most of the time, the log where it says the a, most of the time that's just going to be a 10. So in example 6, it says use the change of base formula to find the following with a calculator. Now, log in A, log base 5 of 8. You cannot do your you cannot use your calculator for that because the base is 5. Your calculator only does base of 10. So the change of base formula is very, very easy. So what you're going to do is do log of 8 divided by log of 5. The little base is in the denominator. So log of 8 divided by log of 5 is just put them in your calculators separately. So the log, so I'm hitting in my calculator right now, log of 8, and that gives me 0.09031. Go with 4 decimal places, please. And then do log of 5 in your calculator. So 0.6990, if I'm carefully rounding to 4 decimal places. And then divide 0.9031 divided by 0.6990. And you'll have your answer, 1.2920. So there it is. So remember what this is saying. This has to do with exponents. So that's saying, like, if we were to check that, that's 5 to the power of 1.292 is approximately 8. I'll repeat that. 5 to the power of 1.292 is approximately 8. So let's do another one. Letter B. So log base 4 of 100. Again, I cannot do this in my calculator because it has a base of 4. Calculator won't do that. So use the change of base formula. Log of 100 divided by log of 4. So go to your calculator, put the log of 100, and that's actually easy. That's 2. You could have actually done mental math there. The log of 100 is always 2 because remember, that's the common log, so it's a hidden 10. And then 10 to the power of 2 gets 100. And then the log of 4 is 0.6021. And then we're going to use the calculator again to divide. 2 divided by 0.6021. And we have 3.3217. So that means 4 to the power of 3.3217 is approximately 100. Let's try another one. Letter C. Remember, the little base is the denominator, so 50 will be on the top. Log of 50 divided by log of 200. So go to your calculator, log of 50. 1.6990, carefully rounding there. And then back to the calculator, log of 200, 2.3010. And then I'm going to divide those. 1.6990 divided by 2.3010. And I have 0.07384. Okay, next part. The change of base formula can also help you evaluate logs without a calculator. We can use the change of base formula to find the following without a calculator. Now, this can get a little bit tricky. So when I'm trying to do this without a calculator, I'm trying to think, what can I put, again, without the calculator? What can I put, bear with me here. What number can I put in those squares that has exponents that go into 27 and an exponent that makes 9? I'll repeat that. What number in the square could I then raise to an exponent to get 27 and also raise to an exponent to get 9? That answer, if you want to pause and think about it, that answer is actually 3. Now let's make sense of why it's 3. Remember, we're thinking exponents. 3 to the power of what gets 27? 3 to the power of what gets 27? That exponent would be 3. Now the denominator. Use mental math here as well. 3 to the power of what gets 9? 3 to the power of what gets 9? That would be 2. 3 to the second power gets 9. So there's your answer, 3/2. If you want to change it to 1.5, go ahead. Okay, let's try letter B. This one is actually quite a bit trickier. We got to think, what number can go in for the squares that has exponents that raise that number to 32 and also to 16? What numbers could that be? Pause now to think about it. Now the numbers are actually 2. And here's the reason. 2 to what power is 32? You can use your fingers here, like we learned in part 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I have 5 fingers up on the side, so that exponent would be 5. 2 to the 5th power is 32. Now what about 2 to the power of what is 16? What would that exponent be? Again, use your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 fingers. So 2 to the power of 4 is 16. So there's my answer, 5/4. Okay, letter C. Log of what? Log base what of 3 divided by log base what of 9. What could those numbers be for the squares that would make an exponent raise it to 3 and an exponent raise it to 9? Well, it's actually only 3. The top, pretty easy. 3 to the power of what is 3? What is it? 1. 3 to the power of 1 is 3. And the bottom, 3 to the power of what is 9? 2. 3 to the power of 2 is 9. So your answer is just 1/2. Okay, let's try another one. Letter D. 100,000. All right, what could I have here that goes into them with exponents? Pause now to think about it. it would actually be, it's simple, 10. Bear with me to rewrite this in. 10, also known as the common log. Now, the rule for 10, when you have a base of 10 and you have a number like 100,000, you just count the zeros. So that would be 5 zeros in 100,000. So that would be 5. And then log base 10 of 10 is 1. 10 to the power of 1 is 10. And then just divide. 5 divided by 1 is 5. And that's it. You're now prepared to do, if you scroll down, you're now prepared to do numbers 69 through 78. So in 69 through 74, you're just going to use common logs and the change of base formula. Use a calculator for that one, for that section. And then 75 through 78 says find the logarithm using natural logs and change of base formula. So I'm going to show you how to do 75 here. So we're going to use natural logs. That means ln for natural logs. So if we want to do this, it's actually very simple. You hit ln of 12 in your calculator, ln of 3 in your calculator. I'll do that now. So ln, the ln button, then 12 would be 2.4849. And then ln of 3 would be 1.0986. And then divide them. 2.4849 divided by 1.0986. And we have 2.2619. So again, remember this has to do with exponents. So 3 to the power of 2.2619 is approximately 12. All right, guys. So again, you're using the calculator here. There's no mental math in the homework, just using a calculator.